Good morning, one and all. I am Sachin from Mysuru and my subject is chemistry. Today in this class, we are going to learn about very interesting topic that is carbonyl compounds. That is carbonyl compounds. What are carbonyl compounds? Carbonyl compounds are the organic compounds in which they are containing carbonyl group as a functional group. In which they are containing carbonyl group as a functional group. That is C double bond O. For example, for example, aldehydes and ketones. The general formula of carbonyl compounds is CnH2n CnH2nO. This is the general formula of carbonyl compounds. Now, what are aldehydes? Aldehydes are the carbonyl compounds in which they are containing carbonyl group, that is C double bond O, as a functional group, and the general formula of aldehyde is RC double bond OH. Here in aldehydes, the carbon atom of the carbonyl group is bonded to the hydrogen atom and alkyl group of aryl group. If R is alkyl group, then it is known as alkyl aldehyde. For example, acetaldehyde. For example, acetaldehyde. If aryl group is bonded to the carbon atom, then it is known as aryl aldehyde. It is known as aryl aldehyde. For example, benzaldehyde. For example, benzaldehyde. There are some naturally occurring aldehydes, such as chinam aldehyde. This is okay. There are some naturally occurring aldehydes, such as salicyl aldehyde. This is known as salicyl aldehyde. Salicyl aldehyde, which is from meadow sweets. Meadow sweets. And next one is vanillin. This is known as vanillin, which can be occur from vanilla beans. Which can be occur from vanilla beans. Vanillin from vanilla beans. And then next one is chinamaldehyd. This is known as chinamaldehyd, which can be occur from cinnamon. Which can be occur from cinnamon. Now, uses of aldehydes. Uses of aldehydes. These aldehydes can be used for flavoring agents. These aldehydes are used as a flavoring agents. Flavoring agents, and it is also used as perfumery agents. It's also used as a perfumery agents. Clear? Next one is structure of carbonyl group. In a structure of carbonyl group, the carbon atom of the carbonyl group is sp2 hybridized, and the bond angle between the three substituents are carbonyl carbon are 120 degree or 120 degree, and the carbonyl group is polar in nature. Polar in nature. Carbonyl group is polar in nature. Why? Because the oxygen atom is more electronegative. It acquires partial negative charge, and carbon atom will acquire partial positive charge. By this, the carbonyl group is polar in nature due to oxygen atom is more electronegative. And the shape of the carbonyl group is trigonal planar. Trigonal planar. Carbonyl group, there are three sigma bonds, that is 1, 2, and 3 sigma bonds will be there, and 1 pi bond. There will be a 1 pi bond. Next, now we will see about preparation methods of aldehydes and ketones. Preparation methods of aldehydes and ketones. Aldehydes and ketones can be prepared from oxidation of alcohols. It can be prepared by oxidation of alcohols. For example, primary alcohol, that is ethanol. For example, primary alcohol, that is ethanol. Ethanol is on undergoes oxidation undergoes oxidation in the presence of PCC, that is pyridinium chlorochromate. When primary alcohol, that is ethanol, is undergoes oxidation in the presence of PCC, that is pyridinium chlorochromate, to form acetaldehyde to form acetaldehyde to form acetaldehyde. Okay. Next, when secondary alcohol, that is propane 2-ol, it is known as propane 2-ol. Propane 2-ol is on oxidation in the presence of PCC. In the presence of PCC, to form acetone. To form acetone. To form acetone. Clear? Next one is dehydrogenation of alcohols. Aldehydes and ketones can also be prepared by dehydrogenation of alcohols. For example, when primary alcohol, that is ethanol is on reaction with copper at the temperature of 300 degrees Celsius to form at the temperature of 300 degrees Celsius to form acetaldehyde. To form acetaldehyde. Aldehyde. And then secondary alcohol, for example, ethane 2-ol, sorry, propane 2-ol, that is propane 2-ol, propane, that is secondary, okay. And it also, okay. Next example is, okay, acetaldehyde. Then, when secondary alcohol, that is okay. Next, secondary alcohol, that is propane 2-ol, that is propane 2-ol, propane 2-ol is on reaction with copper, is on reaction with copper at the temperature of 300 degrees Celsius to form ketone, that is acetone. This is known as acetone. Clear? In dehydrogenation of alcohols, primary alcohol is react with the copper at the temperature of 300 degrees Celsius to form acetaldehyde, and secondary alcohol, that is propane 2-ol, is on reaction with copper at the temperature of 300 degrees Celsius to form acetone. Okay. We can also prepare the aldehydes and ketones from hydrocarbons. From hydrocarbons by ozonolysis of by ozonolysis of ozonolysis of alkenes. By ozonolysis of alkenes. For example, when ethene when ethene is on ozonolysis, when ethene is on ozonolysis, it forms it forms formaldehyde. It forms formaldehyde. Where 2 mole of formaldehyde, the double bond. See here, the double bond will be break and it forms 2 mole of formaldehyde. Next, prop 1 in. Next one is prop 1 in. This is a prop 1 in is on ozonolysis. It forms acetaldehyde, that is CH3. CHO is known as acetaldehyde and formaldehyde. Right? Formaldehyde. Here, the double bond will be break, which undergoes ozonolysis. It forms acetaldehyde and formaldehyde. Clear? Next, tetramethyl ethylene. Next one is tetramethyl ethylene. Tetramethyl ethylene. When tetramethyl ethylene is on undergoes ozonolysis, is on undergoes ozonolysis, it forms 2 mole of acetone. It forms 2 mole of acetone. Here, the double bond will be break and it forms, which undergoes ozonolysis to form 2 mole of acetone. Clear? Next one is by hydration of alkynes. By hydration of alkynes. For example, when ethyne, when ethyne is on hydration in the presence of sulfuric acid, that is H2SO4, and silver sulfate HgSO4 at the temperature of 300 degree, sorry, at the temperature of 333 Kelvin. Okay, it forms an unstable compound. It forms a unstable compound known as enol. It forms a unstable compound is known as enol. Okay, which this is an enol form. which undergoes tautomerization, tautomerization, which undergoes tautomerization to form a stable compound known as acetaldehyde. To form a stable compound known as acetaldehyde, which is an enol form. This is acetaldehyde, which is in enol form. Sorry, enol. This is a keto form. Okay. See here once. When ethane is on hydration in the presence of sulfuric acid and the silver sulfate, okay, at a temperature of 333 Kelvin, to form an unstable compound known as enol, which undergoes tautomerization to form a stable compound known as acetaldehyde. Okay. Next one is when ethane, when prop 1 when prop 1 okay, when prop 1 is on hydration hydration in the presence of sulfuric acid, that is H2SO4, and silver sulfate HgSO4 at the temperature of 333 Kelvin. At the temperature of 333 Kelvin, it will form a unstable compound, which is form a unstable compound, which is form a unstable compound, which is in enol form. Okay, which undergoes tautomerization, which undergo tautomerization to form acetone, to form acetone, to form acetone. Clear? When prop 1 is on hydration in the presence of sulfuric acid and silver sulfate at the temperature of 333 Kelvin, it forms an unstable compound known as enol, which undergoes tautomerization to form acetone. To form acetone. See here the double bond will break and it shift to here. This hydrogen is transferred to the carbon atom, and here also. Here, the double bond is shifted here, and the hydrogen is transferred to the carbon atom. Clear?